So it looks like we got more geometry here. You got onto circles, huh?
Yeah, we're back at circle.
I wondered when anybody was going to get to circles because I hadn't had any students that had it yet.
Well, this is just review.
Oh, really? So you have actually had that?
Yeah.
Okay, well, maybe I missed it somewhere along the line. All right, hold on a minute. Start at the beginning?
Sure.
Okay. What's the radius line?
FK.
What's a common tangent?
Tangent, CD.
That's a single tangent. But it's not obvious that that's tangent to the big circle because they didn't draw it all the way. Maybe tangent to the big circle, may not be. But AF is tangent to the big end, the little circle. Tangent line, you know, a secant line.
EH.
Yep. The center?
K.
Point of tangency.
C.
A chord.
GH.
A diameter.
FJ.
Okay. Talk about number 9. Find the value of the variable. What kind of triangle is that and why?
It's a right triangle.
How come?
Because the tangent has to be perpendicular to the radius.
Correct. Any tangent line always makes a right triangle with the radius. So, this is 3. Can't see what those variables are, but what do I know about them? They're both the same because all radius lines are the same. This is 5. So what equation can I write? Even if I don't have the original equation memorized, what has to be true if that's a right triangle?
They have to add up to 180?
Now, Pythagorean Theorem.
Oh.
Nothing more basic in geometry than the Pythagorean Theorem.
A squared.
How to solve right triangles, yes. So how does that translate to this?
R squared plus 5 squared equals R plus 3 squared.
Yeah. And now I can solve that. R squared plus 25. What's the rest of it?
R squared and 9.
No. Most common mistake made in algebra. Multiply R plus 3 times R plus 3. Use FOIL if you have to.
R squared plus 3R plus 3R, so 9R.
6R.
Oh, 6R, yeah, sorry.
Plus 9. And, you know, this is worth talking about more, actually. Just in general, for all the tests you're going to take and everything else, you want to know how to do this. You also want to know how to do this. That is a squared plus 2ab plus b squared. In other words, you don't want to always have to take the time to FOIL it. If you can memorize this, you can save yourself gobs of time. Now, if I said, what is 3x plus 4y don't have to FOIL it. You can use this formula. What would it be? What's A?
Wait. What's A?
Huh?
Not in 9x squared?
Well, A is 3x. So
Yeah.
what's A squared?
9x squared.
What's B?
16y squared.
What's B?
Oh, 4y.
Okay, now what's 2AB? Because that's what's next.
Oh, 2 times 4 plus 3x. So
That's 2 times A times B. So you have 2 times A times B. What is that number?
that's 24xy.
Right. And finally, what is B squared?
16y squared.
Right. And notice that if you have this memorized, both of them, it's much easier to do these operations where you're having to square something. And notice the difference between A plus B squared and A minus B squared. There isn't much. The only term that's different is that middle term, and it has a negative sign instead of a positive sign. So memorize that, and it'll be very useful to you. For one thing, you won't make that common mistake. And this is what I've read, the most common mistake made in algebra is saying that that's x squared plus 1. And it isn't. It's x squared plus 2x plus 1. So you'll avoid making that common error, and you'll save yourself time if you can memorize these two. Now, back to solving for R. What's the next thing I can do here?
Combine like terms.
Okay? There's a real obvious thing you can do right off the get-go.
Subtract 9?
Subtract R squared. That cancels with that. If you've got the same thing that's being added on the left and the right, then basically what I'm doing is subtracting R squared from both sides. Okay? Now it becomes a relatively simple problem. Now what?
Subtract 9.
Okay, so 16 equals 6R. So R equals 16 divided by 6 equals 8/3. And we solved for the variable. There's nothing wrong with using the exact technique I used. I do think that there might be a slightly more straightforward equation when dealing with tangent lines, and this picture here, I'm trying to remember what it is, but I don't think it's going to make it any easier, actually. I don't think there's any avoiding doing exactly what we did, now that I think about it. So what about number 10? It's true about...
Well, that's the same one as the one before, right?
Pretty much. Give me an equation I can use.
Oh.
I don't care about solving the equation. Just give me the equation.
I don't know.
It's a right triangle, right?
R times, I have no clue.
Start with the short sides of the right triangle.
Would I use like the 30, 60, 90 or something?
No, that's just a right triangle. Use the Pythagorean Theorem. As I said, there's nothing more important than the Pythagorean Theorem. You want to be able to use it instantly, quickly, and correctly every time. It's something you're going to have to do hundreds of times in math. So that's a great skill to have, how to solve a right triangle.
4 squared plus r squared equals r plus 2 squared.
And that basically becomes the same kind of problem as what we had before. Identical, in fact. In fact, you can see that when you square that, you're going to end up with an r squared term, which will cancel, and you'll end up with a linear equation that will be simple to solve for r. Okay? Let's not waste our time going through the arithmetic. Let's do 11. Let's get these set up, and I'm going to count on you being able to solve the algebra. For 11, what has to be true?
2x plus 7 equals 3x minus 5.
All right. Solve that. Let's just periodically check your algebra here. Tell me which side you're going to take the variable to and which side you're going to take the constant to.
I took 2x over to the right and negative 5 over to the left.
That's the best way to do it because it leaves the coefficient of the x as a positive coefficient. Now we don't have to worry about dividing by negatives or anything like that. Okay. What's true on 12?
They're equal, or congruent, equal. X equals, or x plus 5.
Now let's solve this one just to make sure you can.
Plus 1. Okay,
It's the first thing I can do without doing anything else.
Eliminate the x.
Now what?
Get 5 to the other side.
Okay. So we got 0 equals 9x squared minus 4.
No, get the, wait, don't you want to put the 1 minus 5? Or like 1, take the 1 to the left side of the equation.
That's smarter because there's no x term. If there were an x term, we'd always want this to be equal to 0 and we'd solve the quadratic. But if there's not an x term, it's actually easier to solve this way. Kinda. You'll see why it's not necessarily. Go ahead and solve that.
4 over 9 equals x squared, and then square root of that. 2/3.
No.
What?
It's plus or minus 2/3.
But don't you have to square root?
Whenever you solve an equation by taking the square root of both sides, you always, always, always begin your answer with plus or minus. Everybody forgets, and I'm not kidding you, 95% of my students forget the plus or minus. And you can't. It's part of the answer. Now, let's go back a step, and I'll show you a way where you would never forget the plus or minus. Let's go back to the way we had it, like that. What's that called? Has a name. Difference. Quaid?
I thought it was,
Starts with difference. There's only one expression that starts with difference.
Difference of 0, I don't know.
Difference of perfect squares. When you have the difference of perfect squares, it always factors into a minus b times a plus b. Okay? Well, this is the difference of perfect squares. 9x squared is a perfect square, and 4 is a perfect square. So how does that factor?
Of a perfect, 9.
Take the square root of that. That's a.
3.
Minus the square root of that.
Minus 2.
And then the other, you don't have to think about it, it's just the conjugate. Whatever we got for this, the other is the conjugate. Okay? Now, notice that when we solve that equation, we get x equal to 2/3 and x equals minus 2/3. In other words, we get both solutions properly. And in fact, there was no chance of making a mistake. Even if I forgot that when you take the square root of both sides of an equation, you begin your answer with plus or minus, I can't make that mistake when I do it like this. And that's always the case, incidentally. If you use the difference of perfect squares, you'll never make the mistake. If you move the 4 to the other side and take the square root of both sides, you might make the mistake. Now, it's not to say that both of these answers are correct. In other words, it's possible one of them might yield a negative dimension. If there's anything we know about this drawing here, is that these things cannot be negative. X plus 5 is not negative. Well, regardless of which answer I use, x plus 5 is positive. Now, let's look at this one. Well, 9x squared plus x plus 1, that's always positive with both answers. No matter which of those answers I plug in, that side's positive, that side's positive. So both are legit. And you have two answers for this. The one thing about geometry that you have to be careful with is that you can never have a negative dimension. But you can certainly have variables that are negative if they don't produce a negative dimension. Notice that my minus 2/3 still produces a positive dimension for PS. And my minus 2/3 produces a positive dimension for this, because the first thing that happens is it gets squared. And then I'm adding 1 to this negative 2/3, that's positive. So this whole thing has to be a positive number, even when I use the negative answer for x. So don't assume that just because x is negative that it's not a valid dimension. Because notice that these weren't x, it was x plus 5, and this was the quadratic involving x. All right. Let's see if we can find an interesting one that's different.
What about 14?
Yeah, 13's the same as 11 and 12. We're just going to take that, set it equal to that, simplify, solve for x. 14's a little different. First of all, this tangent line is not the same as this tangent line. Notice that this tangent line goes to a smaller circle.
But doesn't it have to be equal though? Because it's
only if it's a tangent that goes to the same circle. Notice that in 11 you have two tangent lines going to the same circle, same in 12, same in 13. So we know that 4x plus 7 has to be equal to SQ. So I can say 4x plus 7 equals SQ.
But SQ has to be equal to SR.
You're right, I didn't see it at first. So 6x plus 9 also has to be SQ, and since SQ is equal to XQ, now you can say that 4x plus 7 equals 6x plus 9. But you couldn't really say it at first. In other words, just because you have two tangent lines that go to two different circles doesn't make those two tangent lines equal. In this case, because of the line in the middle, it does. So you can solve this easy enough. Ooh, what happens when I solve this? What do I get?
Goes x equals 0.
No, x equal minus 2x.
I mean,
minus
1.
So x equal minus 1. Does that make it a legitimate solution? Yeah.
No?
Yes. In other words, there's nothing wrong with x being equal to minus 1. The length of that line is now 3. And when I plug in x equal minus 1 here, the length of that line is 3. So as long as I get a dimension that's positive, there is nothing wrong with negative x values. The only thing that's wrong is when you get a negative dimension. You cannot have negative dimensions. But you can have negative variables. What is arc ED equal to in 10.2?
ED is equal to 30.
Correct. The arc. In other words, it's the same as the central angle. Okay, what's arc EB equal to?
That's 75.
Okay, how about arc EC?
30. Wait, EB isn't equal to 75.
AB. EB. My apologies. My apologies. Yeah, you're right.
That's 105, so it's equal to 75.
The central angle from E to B is 75 plus that. Well, I know that's a diameter, so this whole thing has to be 105 minus 30 this has to be a 75-degree angle also. So if EGA is 75, what's the arc measurement from E to B?
75.
That'd be from A to B. From
Yeah, but it's a diameter.
to B. What's it look like?
105.
No. It's
Huh?
the measurement of that central angle. That's 30. That's 75. We need the measurement of that angle right there. That is what makes up the arc E to B.
So it has to be 70. Yeah, because that's if you look at the diameter, that half
Right.
of the circle.
No, you're absolutely right. That's 75. So what's the measurement from E to B?
Oh, I see. So then it has to be 150.
Right. In other words, it's the measurement of the entire central angle from E to B. Okay, E to C.
E to C.
What's this
So
angle?
that's 30.
This angle right there.
75.
Okay, so what's
30, so it's 100. And this is 75. Oh, I can just use...
that's 30. So we have 30 and 75.
105.
Correct. And what's that? 18 say BEC?
Yeah.
So we're going from here all the way to there.
Be easy, so 75 plus 150, 180,
250.
255.
Right. All right. It's a good stopping point. That's the way you handle all of those. In other words, as long as it's being measured from the center of the circle, the measurement of the arc is the same as the measurement of the central angle. All right?
Mm-hmm.
All right, Quade. Talk to you later.
All right, bye.
Bye-bye.